Developer interview series number 18, I guess, in the meantime. Today it's cloudy outside and it's raining actually, which is kind of weird. Coming back nicely tanned after a great weekend and just jumping into all kinds of clouds and yeah, I don't know. Things happen. Today is a special edition of my developer interview series because we are going to see something that's never been aired before. And the good part is we're talking about a brand new technology that's everywhere. It's kind of the buzzword, not only this week, but since the beginning of the year already. And I'm very happy to welcome Thomas Qvarnstrom today. Hello, Thomas. How are you?
Hi, Marcus. I'm good. And you?
Thanks. As I said, it's cloudy and rainy and I hate it. So bring back the sun in my life and tell me a little bit about yourself. What are you doing?
Yeah, so my name is Thomas Qvarnstrom. I work at Red Hat, and I'm based out of Stockholm in Sweden. We actually have sunny outside.
Nah.
And I'm like 15 degrees Celsius, which is probably around mid-50s Fahrenheit. So kind of okay. Spring temperature, very good.
Okay, what are you working on? I mean, Red Hat, you're a software engineer?
No, so I work for a team called Evangelist team here, and I'm a JBoss technology evangelist, specializing in a couple of technologies, specifically in the application servers in Java EE, but also in teams like DevOps and also looking into microservices architecture. So.
That sounds pretty cool. Let me recap. It's JBoss EAP, it's microservices, it's DevOps. There's only one term missing in that list, right? What is it?
It's data grid as well, yes.
Data grid, right? And Docker, like containers, like DevOps. And you're actually working on something like that at the very moment?
Absolutely. I'm working on how we use Dockers, not kind of how we develop Docker containers, etc. That's an infrastructure part that I don't really have to touch, which is good. So I'm working on how we actually use Docker and how we can be efficient in doing that. So that's part of my job as well. So that's what we're going to focus on a bit today and going to show today, is how you can use Docker containers in development, but also how we can use it in deployment pipelines.
Oh, awesome. I mean, you know that I'm a Java EE developer for a living, so you got me pretty excited. Tell me what we can do with all that container magic and how that makes my life easier as a developer.
Absolutely. Should we start screen sharing here? So
yes, please.
A bit of thing. So let me know when everything is up.
I'm still here. That works.
Oh, you can see my screen?
Yes.
Oh, cool. Yeah. I just wanted to let you know if you can see my screen. So, Docker and Java EE, and as a developer, well, one of the perks with development sometimes is that you end up having to do development, and you do development on other operating systems than you're actually doing in production. And even if you are doing it on something like Linux or which is close probably to what you're using in production, it's still going to be a big gap between your production environment and development environments. So one of the good things about Docker containers is that we can actually run, at least for development purpose, we can run Docker containers that are extremely that are configured the same way that we're using in production environment. And we can even use base images having similar packages or same packages installed, etc., and just have small variation between the development environment, test environment, and production environment. And let me go a bit into that. Actually, I said small variations. Some people wanna claim that we can do basically build once and run everywhere with Docker container. I think that's a bit of an overstatement. That requires a lot of your application. It requires a lot of your configuration management, etc. And it's what we see is that yes, if you're using microservices architecture and you're adopted DevOps, then you might be likely to be able to actually deploy containers all the way from development up to production. But very many companies will still have the problem that they're going to have small variations between different environments, but you want to keep those variations as small as possible. So that's the key, because the less variations you have between environments, the better tests you're going to have and the better production environments quality you're going to get out of your application as well. So without any further ado, let's dig into this quite quickly. So I'm actually first going to start up a Docker container here. So let me clear out that command. So we have, I'm using something called Docker Compose, which allows me to specify actually doing a bit of local orchestration. It's not advanced orchestration where I can have containers on different servers, etc. But Docker Compose, it's come natively out of Docker, and it's very powerful to use. I'm also using boot Docker for running Docker inside Mac, but you can also use it inside Windows, etc. So the first thing I'm going to do is I'm going to start up my little development server here that I have. So let's start that up. So that's how quick it is. It's now up and running, and I actually have a tool called Kitomatic that can illustrate and give you a view of the container. We can see the log files from starting JBoss here, and we can also open a browser and look into JBoss EEP here. So now I'm looking, I can go into the administration console. I'm going to an administration console. I can check whether I have any deployments here, for example, and currently I have no applications deployed here. So what I'm going to do now is I'm going to go to my Java EE project. The first project I have is a very simple project, and this is to make it easy for you to follow along. We're going to do a more advanced project later on. But so initially, I just have a simple application, a web application. It basically has a very simple index HTML, which well, I should remove the preview here, so it's to source, which is just going to give you a welcome and give you some more additional text as well, basically. So my Maven I configured to build, and it also uses the JBoss AES Maven plugin, which is great for doing deployment, and you can also do remote deployment. So what I've done here is I actually added the IP address of my Docker container, and I'm also running which port I'm running, and then I have the username and password for the administration console. So by doing this, I can very easily, and I have already configured a Maven task, which basically just does package and then does JBoss-AES :deploy. So by running this, let's wait for Maven a bit. Here we go. So now I have deployed the application. So let's go back to the deployment scene here, and now we can see they have the simple application deployed here. And actually, if I change here, I can go to my and see the page here. So that's quick, and that's key for whatever any developer wants. That's really key for Docker. Docker starts up and can be very efficient and very low on resources as well. So it's extremely quick to do round trips, for example. So let's show that. Let's do round trip and say welcome. Let's do that, and we build it one more time. And actually, when you do the round trip here, you notice that actually it's Maven that's slow compared to all the other things going on.
But correct me if I'm wrong. I mean, this is basically what we all have as a local development setting, right? So the only hassle you didn't have to do is actually unzip EAP and start it.
Exactly. We're going to go and show how the Docker image looks like and how it's based in a minute. I'm just going to show that here we now have welcome developers, so it's already deployed in the application. So what's the magic behind this then? Well, let's sorry, wrong window. Let's check the magic here. So if I actually go into the terminal here, I think. Oh, sorry, I'm going to do it here. So actually, let's do it like this. Sorry. Yeah. So where am I? I'm going to go into my project here. So the product I got here and the image we're using, the Docker container. Docker is based, it builds images, and Docker, the nice things about containers in general and how Docker works with containers as well, but containers in general, is that we actually are not spawning a full environment like we do in virtualization. we're only spawning a small process inside your existing container or existing hosting operating environment. If you're using Mac or Windows, you have to use one virtualized environment, but running one virtualized environment is fine, and it's all taken care of behind the scenes. But the nice thing is that every image that you start or every container that you start within that will just be another process on that machine. But that process is totally isolated, etc. And it can have different installation packages, etc. And what I have here is basically that I have a couple of build images here, and I have something called an app server base. Let's actually first check app server dev. So app server dev is a very simple container. It basically contains two easy statements here. It sets two environment variables, and these are environment variables enabled for development type of. I wanted to have a very fast starting JVM and running very fast. So I enabled some of the JVM options here that are available for that. So running it as a client. I also lowered the memory footprint and gave it some other things. And basically that's all I've done. And if you can see, I'm using a layer structure here. So I have another base image. And this app server base can be the same app server base that we're using in production for containers later on. So let's check the app server base image then. So the app server base, it contains a bit more infrastructure. And the key thing is developers probably don't have to maintain this themselves. If you're skilled about it, and you're and probably you will have one in your team that are skilled in DevOps type of mentality, he can maintain this file and make sure that all the necessary package and configuration of your operating system is done inside this file. So just to give an example here, what I do is first, when this container is created, I installed a specific version of Java. This could be a version that you have, or this could be another type of version that you're running in production as well. I'm also adding a JBoss user because I'm going to run this as JBoss user. I don't want to run it as a root here, and then as another user in production, because that's going to have different. That's going to be a lot of different configuration and potential for missing issues that we have. And just to give me one more example. So this is the command where I actually unzip and install JBoss EAP, and this is the command where I start JBoss EAP. So that's a very simple explanation how the dev environment can look like. And let's go back to here, I think. So any questions, Marcus, around development?
I was wondering how the container actually separates between downloading and unzipping and just starting. I mean, you started the container in what, a millisecond or something like that?
Yeah.
And I can't believe that it does all that fancy magic like adding users and unzipping and whatever in that millisecond.
Absolutely. There's a build structure that I have to go through as well. So building that, what I actually just did was starting an already built container. But actually building containers, because we're using this layer of images that we're doing, so building a container is actually very, I can show here, it's going to go very fast right now because I have everything cached locally, etc. Initially, when you run this, you will probably have to download some base images from a repository, and probably depending on what you have then in your build script in regards of downloading other software or etc. It's going to take a different amount of time, but that's a one-time effort you have to do. So basically, by doing this, you can see that this command will actually run all the build setup, etc. And it's running so fast we can't really see what's happening, but that's the build infrastructure. But if I want to change, for example, the Java ops here, you can see that it will actually take a bit longer. So let's go to TextMate, and we go to the correct Docker file, the dev, and let's say we want to change this to 128 instead. Oops. And for clarity, probably I can actually build it while running here and then restart it, but let's actually remove the running container here so we don't have freeing up the resources, etc. Now, if I execute the build command, everything goes fast up to that point, and that point is probably quite quick as well, so you didn't see that. But if that would be a download, it will stop there. And that's because of the layered file structure that Docker using. So it's caching the intermediate, and after each command, basically it's caching where we are at the current state. So if you change at one line here, that's where it's gonna kind of start up from where you added your changes, and then it's gonna build from that.
Okay, that's pretty convenient. So pre-built images can be just directly used and started as container instances.
Absolutely. So, but one of the things that there is a lot of pre-built images, but next we're gonna see a full CD environment. One of the things I find that, and I want to stress this a bit, is that there is an official, for example, an official Jenkins image here, and it's perfectly fine to use that official Jenkins image. But you have to understand as well that, for me at least, when using Jenkins, there's a lot of setup to do. So this comes basically empty. It doesn't have any jobs. It has very few plugins, etc. So the first thing I have to do is do all that configuration. And if I do that actually in a container that's running, and I do that configuration through the web interface, etc., then it's going to be kind of hard to recreate exactly that. So I actually rather do that in a way that I can automate and recreate that. So let's have a look, for example, at a Jenkins configuration file that I have. So this is a Jenkins configuration file that I got, and here you can see that I'm downloading some plugins in the build. So that's also happening when I'm doing the build, and then I'm adding some configuration. I'm adding some works, some jobs here, so we can actually build things here.
So what's behind that? You basically say that containers are immutable, like I can configure an image and spin up a container instance, and that keeps running and does everything. And whenever I change something and restart the container, it's lost.
Yeah, so there is a possibility to actually save an existing state of a container. But the hard part is if you lose that file in any way, or if you don't back it up or anything like that, it's really hard to recreate that container that you've done a lot of manual configuration. And it's like any manual configuration. As soon as you do manual configuration, the risk is also that you actually do something wrong. Here, if you do something wrong, we can easily change the script and how that works, and we can adopt it and make sure that it's going to work perfectly each time that I build and run this. And it's also going to be easier to distribute this Docker file, which is a couple of K, compared to distribute a full saved image, which could be anything from a couple of 100 megabytes to 1 gigabyte, depending on the content of the image, actually.
Okay, makes sense. Yeah.
So let's look how that looks like. So when you want to do more advanced development, you want to do continuous delivery type of development. So one thing that's troublesome for many organizations is to have central Jenkins servers that have to scale out. They have to have a lot of workers to do all the job, and they're always getting bloated and running quite slowly, actually, to be honest. So one nice way to do that is actually to have your containers and your Jenkins container running locally, but they're based on the same image, so they're preloaded with the same kind of jobs, etc. But that means that I'm actually going to run it locally here. So let's start that up. I'm just going to check that out. Stopped everything. Yes. So let's today. So I didn't explain this YAML configuration. I can show you that later. But so let's specify that I want to start my development environment, basically. So this is going to start 3 different containers. It's going to start one Jenkins, it's going to start one Nexus, and one Sonar, which is going to help when I build and how we do that. So if I now go back to the illustration, you can see I have now 3 different containers here. So one Sonar container, one Nexus container, and one Jenkins container. That one is old. It's now hasn't started.
Well, that was blazing fast.
Yeah. So this Jenkins is still probably warming up here. You can actually, if you open the browser here, that's a cached one. So, and then we go to Jenkins, you'll see that this particular welcome message you're used to see if you install Jenkins. But it's going to take 1 minute or 2, and then Jenkins is going to be up and running and configured with the jobs that I'm going to run as well. So let's give this a couple of seconds. Any questions meanwhile, Marcus?
Let me think. I like the idea. What I really hate from with it is boot to Docker and the virtualization layer I have to use in Windows. Yes, I'm using Windows. So is there something that could make development easier on that end? Or is how long will it take to have a native Docker integration somewhere? Or is there another container technology that will make my life easier?
Both the Docker community and Red Hat participating in that is working on this to make it even more streamlined and even better. But eventually you're going to have to run it in a virtualized container. You won't even notice that in many cases if you actually have the correct tools. So like this is Kitematic. It's a beta product still, and it's getting better and better. But this basically gives you a view where you don't really have to touch the fact that we're actually running it in container. For example, if I want to log into this Jenkins container in the terminal and see what's happening, I can just click here, and that's going to open up. And if I do host name here, you're going to see that I have a random host name. So I'm actually running this in the container. And if I, for example, want to check my configuration files from Jenkins, but installed correctly, I can go into the Jenkins job directory. Let's do ticket monster. What do we have? Build, for example, and let's do vi config XML. This is my configuration file for that type of build, for example. So I can actually log into my, like I'm working on Linux and the command line on Linux into the terminal, and I don't even notice that I have to do this in a virtualized environment or anything like that. So it's very hidden right now, but it is a virtualized environment behind that.
Okay, looks a little bit more convenient than my boot to Docker configuration on my machine.
Yeah, I think the only real issue sometimes with having a virtualized environment is that you are sharing the resources with your other operating system, so you have to specify enough memory and enough disk. But it's compared to actually, as I see many customers that I've been visiting, they're using virtualized environment for every project. So every project they have another virtualized environment they have to spin up. It takes minutes to start that virtualized environment and have it running, and they can't have two at the same time running, things like that. So compared to that, this is definitely much better and much more easy to work with.
Yeah, I mean, it's not a complete VM, right? So it's, at the end of the day, it's just the image definition, and the rest can be built on the local machines.
Yes. So you can actually share files between them as well. So you can share volume files. So you can directly write from files into your locally into the container as well.
Okay.
So let's skip that and see where our. So this is our Jenkins server up and running now. Everything up and running, and you can see all the jobs. Ticket Monster job here. So maybe I'll spend a minute and explain Ticket Monster. Ticket Monster is a showcase application that we have at JBoss, which shows off various Java EE technologies and patterns to build and use Java EE. It's really nice to look at, and there's a complete guide on how to actually build that project as a full Java EE project. I'm going to use that project now, so I'm actually, you're not going to see much of the actual code here, but what we do is if you look at, we start with the build that I'm going to run, it's actually going to, the first thing it's going to do, it's going to check the project out of Git. So I have a Git repository here where I deploy the Ticket Monster application basically, and then it's going to use Maven package on that basically. And let me start to build, and we can see how we can actually show the whole deployment pipeline. So I'm going to start this this Ticket Monster build here. So we have build scheduled, and now it's starting. So now I have a plugin called Deliver Pipeline, which shows the dependencies between the different steps that we have. So the first one is build package that we just looked at. The next one is a static code analysis. This is basically gonna send the code and documentation of the code, etc., to Sonar, who's going to do code analysis on it. And that's going to happen in parallel with us running integration tests. And if the integration tests are successful, we then move on to the next step, which is system testing. And system testing, we're going to build the actual release. Building the release here is actually where we tag the Git, we tag a Git release in the Git repository. We also upload the result of the build to Nexus. So after this build, we don't have to build it again. So this is going to be the master build, and that's a tag release uploaded into Nexus. Everything we do with the build after that is directly downloading from Nexus, which is our build repository here. And as you remember, Nexus is another Docker container that we use here. And the good thing about Docker and containers here is it takes care of all. We can link those two images together, so I don't have to care about the IP address or anything like that of Nexus. So just by linking it, I can refer to it as hostname Nexus. So it's quite convenient. So let's see what's happening with the build. It's checking out. Apparently my network is a bit slower than this. Doesn't normally take so long. But we'll give it some more seconds. And here we go. And now it's going to start static code analysis and run integration tests in parallel. So this one, as we said, will integrate with the sonar image that we have. So when that's done, we can actually check the sonar image and see regarding the project and see if doing a look at the code analysis and see if suggesting improvements, etc. And as soon as the integration test is done, it's actually going to kick off because the code analysis takes a bit longer, but that's fine. We can run in parallel.
The integration tests actually are done with Aquila, I hope.
Oh, I actually was cheating here. So I've done that. I didn't find time actually to do that. I wanted to do that. But it's a good point, Marcus, that you're making, because actually when we go into here, I'm going to start a container and test the application. This is going to be more a system testable application. And then I'm going to remove the container. And similar thing we could do with Aquila. Aquila gives us the possibility to do in Java EE container testing. And so by using Docker, we can spin off Java EE instances that it looks exactly like our production, use the nice test capabilities that Aquila has to run all the tests and verify the integration tests here. And then when we're done, we can remove that container and free up the resources immediately. Actually, one thing I wanted to say, system test is not going to happen locally. System test is actually done on the server machine that I got, deployed in other side of the world, actually. So you have a bit of ping time. It's deployed in Boston, but this is actually gonna start that container on a full-blown RHEL 7.1 installation that I got server. So that's where I want to test the application. I probably don't want to test it locally. And we can get into why, even with containers, I probably don't want to run all the tests locally. So it's not building a release, by the way. If we check the release, we can see here now that it's doing all that was the Nexus download. Now it should do the git clone, and it do git fetch, and it creates the new release for us. And eventually we're going to get a release number here, I think. Well,
how's the remote container created? Is that also a Maven plugin?
There's actually a Maven plugin existing out there. It's developed by the Spotify team. Spotify music service, it's kind of like Netflix, which is using a lot of containers as well. But I'm actually using native commands here, since my Jenkins is in a container, a Linux container. I can use native Linux commands to actually do SSH only directly into the servers. If you want to see that, it's maybe not so let's check that. Maybe not so nice as it could be in all levels. But basically what it does, it downloads from Nexus the artifact, so I don't have to build it again. And then it does an S copy, because I want to build the image that I'm going to run, I'm going to build that remotely. So, and then I execute this docker compose build command, and then I execute start command. And if I go back here, we're probably going to see that it's already done. Yeah, so it's already created the container. It's now running the tests. Just for fail-safe purposes, I added a sleep in my test, which is about 30 seconds. This is going to take some time, but probably we probably don't need to have it that long. I just haven't figured out what would be a good sleep time. And as soon as that's done, there we go. It's actually going to remove the container. So now it's going to remove the container. And since the test passed and everything worked, it actually started creating a production container for us. So it's creating the container and deploying it in production as well. So this is a continuous delivery all the way.
Just sit back, relax, and have a cup of coffee.
Exactly.
Yeah, it just takes some time, right? So the rest is done automatically.
Yeah, I've used various PaaS services and other things like this, and I must say that Docker here is the thing that takes least time. It's the downloading from the Git repository or doing the Maven builds, etc. And that's taking most of the time actually. So the actual starting of a Docker container and deploying it and starting JBoss is actually quite quick. So now we're verifying in production, so that's also going to sleep for a while. And we can see that. Meanwhile, we can look at, let's do this and take a new one. And we can take, so I have Sonar running locally on the Docker container here. So this is the Sonar project, and this is for the Ticketmaster project, and that's the release version we got, 2.6.32 it was. And here we can see, well, I'm not going to demo Sonar, so but just to give you an idea, this is how much code it is, about 5,000 lines of code, 84 files, so many functions, etc. So that's a quite nice thing.
Actually, Ticketmaster as an application is available via jboss.org as a quick start, I guess. So, and all the code that you're showing today is available on the JBoss Demo Central on GitHub, right?
So yeah, I'm gonna upload the latest versions of it as soon as we release this. So yeah, it's gonna be available on jbossdemocentral.com.
Okay.
So if we go to the creating container here and look at the console output, we can see that it's oh, actually, let's go for the, I went for the wrong one here. Let's go for the verify production. So the verify production is very simple. This could be much more advanced, but basically all it does is querying this URL and make sure that it contains the text Ticketmaster. So of course we could use much more advanced testing frameworks for this, etc. But this is the production environment. So if I click on that one, it should start. And this is on the other side of the world, and that's why it's probably loading a bit slow. But so this is the Ticketmaster application now deployed, fully working and functional. So it's I have to go do something. So it's a very nice way of handling and then managing your deployment pipeline. And as I said, Docker brings in a value of speed here, which is kind of phenomenal, and it gives us a way to use only the resources we actually need. And as soon as we're done using that resources, we can spin that container down, take it down, and we can make the resources available again for development or whatever you want to do. If you want to watch videos or whatever.
Okay, awesome. And the whole process actually can also be triggered by source version control check-ins.
Yes.
So you could just add all the magic that makes working in a team totally decent and automate the whole delivery pipeline, right?
Yeah, and of course, I mean, normal how you would configure Jenkins here is it would be like that, and you would notice that somebody have checked in a new code change, and then it would build that, and then it will then build from that, and you will set up email and notifications as soon as a build goes wrong. And potentially in the delivery pipeline, you want to introduce a human step between system test and production, so that somebody actually triggers the production setting. so that it's not triggered by accident. So one way of doing that is, of course, that we also the same thing. We notify that every system testing has gone fine and everything, and somebody with responsibility gets an email or notification, and they can then, when they feel ready, deploy this on production.
Okay, perfect. Thanks a lot for the demo. That is very complete. I can't wait to see all the source code. I mean, you're actually going to push the image description files also to GitHub, right?
Sorry, yeah, absolutely. I'm on the Docker files. Yeah,
yeah, correct. So people can actually replay that whole thing when they just tweak some more URLs. The discovery actually of the production server is, I mean, that's hard coded still in the Jenkins bash script, right?
Sorry, yeah. So my production server is running internally in Red Hat Network, so that won't be able to do. You won't be able to do those kind of steps 100%. I'll still push out the full source code, so you can use that and everything. But I'm going to remove some of the SSH key just. But I'm going to push out the whole source code, so that we can you can view at least what I've done here, and you won't be able to recreate the production setting, but everything up to production should work fine. Or actually,
perfect.
Yeah, actually, create container is not locally as well. You can move it quite easily to use locally as well, though.
Thomas, thanks a lot for your time. That was a pleasure to have you here. I have a feeling that we are going to talk to each other soonish again. So have a great day and talk to you soon. Bye.
Bye.